Today, I'm pleased to introduce today's session, Safeguarding Data Integrity On-Prem RAG Deployment, and our guest speaker, Darren Oberst. He is the CEO of AI Blocks, an innovative AI platform revolutionizing the landscape of LLM-based application development for generative AI in financial services and legal industries. Prior to AI Blocks, Darren served as the CEO of Exadel and launched and grew HCL software to over 1 billion revenue in 5 years. Darren is currently focused on building enterprise LLM-based applications, which includes retrieval augmented generation, open source LLM middleware, also called LLMWare, and fine-tuning specialized enterprise LLM models for open source. Darren is a graduate of UC Berkeley with degrees in physics and philosophy and Harvard Law School with honors. Welcome, Darren Oberst.
Wonderful, Eugen. Thank you so much. And thanks everybody for joining today. We've got a few slides that we're going to go through, and then we're going to spend hopefully at least half the session in some live demos. As Eugen mentioned, we want it to be really interactive. So post any questions that you have, and we'll certainly stop and make sure we spend more time on some areas that are of interest to everyone on the call. I'm really excited about this. We've been working with Milvus, with the actual technology for the last 18 months. We've had just fantastic experiences with it, and it's really central to the tech stack that we're putting together in terms of a private cloud RAG system. So we're going to try to illustrate that, both bringing to life some of the overall capabilities, but then really, I think, highlight to everyone sort of the central role that Milvus plays as part of that architecture. So let's go ahead and dive in. So really, the goal of today is to get to the demo and look at this thing, a live running private cloud end-to-end RAG system. To really motivate that, there's a handful of slides that we've put together. We're going to give a quick intro into AI Blocks. We're going to keep the commercial to a minimum, but we do want to just help to set some context, some motivation about sort of who we are, some of the capabilities. All of these are in open source, so they're all things that you can go and check out for yourself. We want to set up some motivation around private cloud RAG. I mean, what does this mean? Why would somebody want to do that? Why is this an interesting direction? And then we really want to spend a few minutes laying out a conceptual architecture of how do you bring all of these pieces together, and how can you actually do that in a single private cloud instance? And then the demo scenarios that we're going to look at, I'm going to try to get to 4 different demo scenarios. We're going to run through first 2 scripts that are really just to show you a quick hello world type of illustration of document parsing, text chunking, embedding, and some basic semantic querying, all using Milvus and then wrapped within the LLMWare library. So there are 2 examples of that. They're actually available as examples in our LLMWare GitHub repository, so you can go and check them out, run them for yourself. But we're going to run through those 2 examples sort of quickly. Then we're going to get to a 3rd example, which is actually a RAG scenario that builds off those first 2 scenarios, in which case we're going to bring in a 1 billion parameter LLM that we've trained and fine-tuned for RAG. And then finally, if we have some time, I'm actually going to pop open sort of a pop-up web app, which is a derivation of the multi-tenant, multi-threaded SaaS site that we've been running. And that site, we actually use Milvus. We've massively parallelized it in a Kubernetes cluster. And again, we've had some really great results in terms of scalability. So just to maybe help illustrate some of the retrieval capabilities, we wanted to show you a quick UI just so you can see it, because sometimes it's a little easier than looking at a console screen. So a lot to get to. So let's start with just a little bit of motivation. Why RAG in private cloud? In fact, in many ways, this would seem to fly in the face of so much of kind of the marketing and what the attention that you hear in generative AI today, where just about everything are public cloud API services. So why would anybody be talking about doing this in private cloud? Well, the number one reason is data privacy of sensitive business documents. And a dialogue that we have all the time, almost every single day, and I'm sure many of you do as well. People will start with a pilot, a proof of concept, a validation. Let me impress my boss with what I've got. typically starting with OpenAI, starting with Pinecone, starting with a public cloud deployment, because it's a very fast way to get started. But in many industries and in many enterprises, as soon as it gets real of how are we actually going to start building a system that we're going to be connecting an LLM to our private, knowledge bases, issues around, data privacy, data governance, the sensitivity of moving those documents outside the security zone of the enterprise become paramount. So one story I'll just tell, and I think we all have a bunch of stories like this. We were actually on a panel a few weeks ago. A very senior bank executive was really extolling all the virtues of what ChatGPT could do, what GPT-4, the revolution that it was leading. And so we grabbed this executive, after the session. We said, give us a sense. I mean, what's going on inside your institution? I mean, are you guys rolling some of this stuff out? And the feedback was, well, inside our financial institution, nothing is leaving our security zone, period. So in any kind of real rollout of an LLM-based technology, it's got to be some form of a private cloud. And again, a lot of ways to skin that cat, so to speak, but it would have to be something that would be secure. There's no way that this financial institution would be sending, key business documents, contracts, regulatory information, training collateral, HR information, customer-related information, PII-related data. There's no way that that's ever going to be going out over a public cloud. The second main reason that we hear, and I think this has been really one of the great stories of 2023, is the open source innovation curve has been absolutely spectacular. It's really one of the most revolutionary things I can remember in my lifetime, working in the software industry. When you look at where open source was a year ago to today, it's just an unbelievable curve of the types of technologies, the types of foundational models that are being rolled out and deployed in open source practically on a monthly basis. There is technology that continues to improve and improve and improve. And I think what we hear from more and more customers is that they want to be able to build off of that innovation curve. They don't want to get locked into proprietary technology. And they also see the potential then with open source that they can customize it, they could make it their own. And as everybody starts to digest what LLMs mean, what generative AI means, we see more and more companies saying, we don't want to fully outsource this. In fact, we see this as something that will be integral to our future, that will be part of our differentiation, part of the capabilities that we want to offer our customers and our employees. We want it to be part of our DNA. And what open source models give us the ability to do is to start to customize that. And so the AI becomes not somebody else's AI, but it really becomes an AI that is unique and proprietary to our business. Third big reason is cost. Now, there are a lot of spectacular use cases for LLMs and for generative AI in the enterprise that don't make sense. When you're thinking about every single time I call this API, I need to pay for it. It also doesn't make sense when you start thinking about a model that's 100 billion plus parameters. The cost of the models we're going to show today, which are on the 1 billion to 7 billion range, on an inference basis are probably 100 times cheaper. In fact, maybe several hundred times cheaper to actually deploy. So it starts to become practical, a whole set of use cases that can actually be achieved today once you start thinking about smaller models that can be deployed in a private cloud.
Hey, I just want to pause here for a second. Do you have links for some of the research that you guys have done or seen around this? Because that's actually really cool that it's like so much that the cost is just so much lower. I would love to be able to share that.
Totally. I will get to it in a couple of slides. I'll actually point you. I mean, you sort of teed me up perfectly. I'll actually show you, our GitHub repository. I'll show you our landing page on Hugging Face, which are really places where we have, the models, some benchmarks about the models, as well as a whole series of articles and videos that we've posted around these topics.
Perfect.
Okay. Next. And I think it's going to be one of the themes that I really want to emphasize as we look at the demo today. RAG, retrieval augmented generation. There's retrieval and there's generation. And when you really think about building a RAG system, we think there's so much focus on the generative side and not enough on the retrieval side. When if you get the retrieval right and you have a good retrieval strategy in terms of how you're indexing and text chunking, applying the right type of embedding model, putting it into a vector database, if you have the right retrieval mechanisms, that can carry a lot of the weight. And conversely, if you don't have the right retrieval, all the generative AI in the world isn't necessarily going to give you a great fact-based RAG system. So again, stories like that I hear, people saying, well, maybe GPT 3.5 isn't enough for RAG when we're looking to ask questions to documents. Maybe we need GPT 4, GPT 4.5, or something that's going to come in the future. I think in most cases, in our experience, it's not the generative AI that's the problem. It's in getting both the retrieval strategy right, the packaging of that context information. If you get that part right, oftentimes you can get the same results or results that they're almost as good with models that are much, much smaller. Again, we're going to show you some of that in the examples today. And then finally, we really believe that bringing RAG into the enterprise shouldn't be about bringing the enterprise out to the AI. It needs to really be in reverse. The AI needs to get infused into enterprise processes, into enterprise workflows, and into enterprise knowledge. When you start thinking about doing that in private cloud, the totality of this, it starts making it much easier to start integrating AI into the way that businesses actually operate day to day. All right, what is Dragon? Now, Dragon, we have some cool videos out there with like lots of pictures and stuff, so I'd encourage you to check it out. But what is Dragon? Dragon is a set of models that we rolled out. We just launched them, I guess, about 3 weeks ago now. All of these are models that are posted in our repository on Hugging Face. Dragon actually stands for, in addition to being a cool name, delivering RAG on. It's a model series that we've launched, and we've built 7 models. And the 7 models are a RAG fine-tuning, and I'll explain what that means in a minute, of 7 leading 6 and 7 billion parameter foundation models. Now, what we've actually done is over the course of the last couple of years, we've built up a pretty large proprietary, self-curated, self-developed, bespoke data set on contracts, regulatory documents, complex financial news and information with fact-based question answering and a set of very specific tasks and skills. And so we've built up this data set, and then we've gone through and we've fine-tuned all of these models. And then what we've provided are a set in our repository. And again, to the question that was asked, maybe we'll flip over to that screen. I can show you where the models are. We've provided really easy to get started generation scripts. We've done some really unique things in terms of LLMWare, giving these really first tier support. One of the things that we've seen with a lot of open source models, the problem sometimes isn't the model itself. It's that a lot of the surrounding, wrapper code, the LangChain or Llama Index or LLMWare code that you'd be looking to use don't have a lot of the built-in bells and whistles to really make that model shine. And so sometimes the amount of work that you have to do to get the model fully integrated into the workflow is just so much more than it is with an OpenAI or with an Anthropic. And then finally, we've benchmarked all of these. And we haven't benchmarked them with things like MMLU and ARC and HelloSwag. Again, if you're familiar with the Hugging Face LLM Leadership Board, there's a whole bunch of scientific metrics out there. But the key question we always get asked is, well, does this work? Is it going to give me a level of accuracy that I can count on for the specific workflow that I have? It doesn't have to be perfect. It doesn't have to be 100%, but I need to have some baseline assessment of, is it going to be 90% accurate? Is it going to be 98% accurate? And where are the situations that it's likely to be successful? Where are the areas that it's not? So we built what we would call a common sense RAG instruct benchmark. And then we've run these tests on every single one of these models and published all the results. So if you pick up one of the models, you've got a pretty good sense of the kinds of use cases and the kinds of accuracy that you're likely to get. But most importantly, like if you're really thinking about building, production grade system, you're going to go do something really meaningful in terms of RAG. A llama, man, I don't know if that's what you want. Red pajamas, I don't even know what that is. A falcon is sort of cool, but ultimately what you need a dragon. Dragon is fire. Dragon is the ultimate cheat code. Anybody that's seen Game of Thrones knows dragons are ultimately, the baddest thing out there. And so we thought it was sort of a cool way to brand what our real aspiration is we want to build the best private cloud, 7 billion and under parameter models, putting them all out in open source so that people can build really high quality, state-of-the-art RAG systems at lower cost, all in open source and all on private cloud.
Okay, so this is a good segue into one of the questions that was asked. When you talk about private versus public cloud, can you clarify what the distinction is there? If someone is using Milvus on their private cloud, but OpenAI as their LLM, is that an API request considered using a public cloud? And how so?
So at any point, if information is going outside the security zone of the enterprise, then at least in the context of this conversation, we're considering that, quote, a public cloud use case. And again, imagine, let's say, and one of the examples we're going to take a look at, let's say you take some contracts and you parse and text chunk and embed those contracts and key contract provisions, you're packaging in a context and you're sending that out to an OpenAI. Now, in reality, in most use cases, it's going to be relatively safe, but that is a public cloud use case. And so the situation that we're going to be talking about is everything running in a private cloud context, including the LLM model. So what I'm actually going to show you when we get to the demo is literally everything from the LLM model, the embedding model, Milvus, all running on a single server with the workflow running on that server on a private cloud instance.
Cool. Okay, very cool. Thank you.
Any other questions?
That was the only one that I felt
Okay.
like was good to touch on at that moment. I think we'll let you continue.
Cool. So I've mentioned Dragon. Dragon are a series of what we believe are production grade models. They run on a single GPU instance. And again, in Q&A and through the course of discussion, we'll talk a little bit more about that. But what we've also built, because we saw a huge gap, is for CPU inference models. A very common scenario, going back to the question, when you're actually ready to roll out that application in production, you may be fine actually calling on a public cloud model, depending on the sensitivity of the data. And as you're thinking about, all sorts of review that may go in before that production application is rolled out. But for testing, for rapid prototyping, I'm sure many of you that work with clients or in consulting type of roles, clients have a lot of like wild and crazy ideas. Hey, does this work? Hey, for this type of scenario with this type of document, am I going to be able to get results? Is this going to be able to automate a process for me? Is this a good use case? So what we wanted to create with our Bling models, which are the best little instruct no GPU required models, are actually instruct trained, RAG fine-tuned question answering models that can run inference on a laptop. And we're actually going to show one of these in the demo, but they're 1 billion to 3 billion parameters. And again, all of them have been benchmarked and scored. And one of the things we believe then is you could run some quick tests and quick prototyping with a Bling model. And then as you move into production, you don't necessarily have to go to that OpenAI model. You could go to a private cloud, Dragon model. With the same workflow, all you'd be doing is simply changing the name of the model. And then finally, the last model family that we've rolled out, we're going to see in the demo, is industry BERT. And these are just sentence transformer models that we've fine-tuned. The example we're actually going to be looking at is an industry BERT for contracts. And we did exactly that. We fine-tuned the model with thousands of contracts. So it's a little bit more finely tuned to some of the terminology and language around the contract. Again, we're going to show you an example to help kind of bring that to life. So all of these are kind of the model families. They're all available on Hugging Face. To the question about where to get this, I might just pause here for a second and just show you our repository if I can. Oops, I'm sorry about that. Okay. So this is just one example of a model. Hopefully everybody can see Hugging Face. If you want to go look at the Hugging Face, the LLMWare repository, it's just right there on Hugging Face. This is one of the model cards. This actually is one of the models that we've loaded. Desi is one of our partners. We did another webinar on, so we always like to promote our partners. So this is a 6 billion parameter model that we RAG fine-tuned. What you see for the model card is all the information then, about the benchmark tests, the accuracy, and what we include then with the repository are both the test results, that's these, the answer sheets, as well as the sample script. So you can go ahead and a great way to do a hello world to get started with the model is you can run these generation scripts. It'll run the test for you. So a lot more here if people have questions or are interested, but all the things that I just went through, you can find on our LLMware organization page. These are some of our blogs that talk about some of the benefits of some of these smaller models and all the different considerations and trade-offs. And then you can see the collections in terms of the 3 model families that I referenced. Okay. So coming back now to the presentation. What is LLMware? Again, I don't want to give you a big commercial about it. This is a library that we rolled out. Again, you find us on GitHub, just at LLMware. And what it is, to put it simply, it's a LangChain or Llama index-like toolkit, completely in open source, but it's indexed around these things that we've just been talking about. It's really designed for enterprise workflows, massively scalable document ingestion. Again, we'll highlight that in the architecture. So we've built our own, C-based document parsers from the ground up, full implementations of the specs for PDF, Word documents, PowerPoints, and Excel. And the idea is if you really want to roll this out in an enterprise, you're looking at a problem of thousands, tens of thousands, hundreds of thousands of documents. You need to be able to parallelize that and distribute it across multiple workers. And so the first thing that we've really focused on is massively scalable document ingestion. We focus on an end-to-end data model with persistent data stores. So Milvus comes in any use case around LLMware. We also use MongoDB integrated into our parsers as a text chunker and a text collection index. And then our real priority is in building out a framework for building LLM-based applications with open source models, not as an afterthought, but really at the foundation. So we're constantly building out new features and capabilities to support a wide range of open source and Hugging Face models, and then really leading with the models that we've just discussed. Super easy to get started, and again, a bunch of examples that some of which we're going to highlight through the discussion today. All right, now that we've sort of set up all the different pieces, I want to bring it all together. So I want to show a conceptual architecture of what a private cloud, an end-to-end true private cloud, so everything is in the box, what that architecture might look like. And then we're going to flip over and we're actually going to start running some demos in it. Okay. So where it starts conceptually is ingestion. And as I said, as part of LLMware, we package our own parsers. They're really high speed. You're going to see an example of that. They're also very, very high quality in terms of the richness of the metadata that they gather from that document and the consistency of that metadata, which we're able to use then pretty extensively as you move down a data pipeline in terms of retrieval. And then ultimately, after you've done some sort of LLM call, to be able to pull back on that metadata to identify, where was the source and what was specific information about that source. As I mentioned, it's fully integrated the parser with a MongoDB text collection. We extract a chunk of text, we populate that database. Ultimately, and again, you're going to see that in the example, the Milvus vector and database is really at the core then of this conceptual architecture. We're going to use, in this demo scenario, small, specialized, open source models that we fine-tuned for this purpose, the industry BERT models, and then we're going to use the Dragon series. We're going to use a Bling model as well for the LLM. And so the flow of this, as we're running the embeddings, all of the information is text chunked. It runs through the industry BERT embedding model, and then all of those vectors are stored in the Milvus database. And then from a conceptual point of view, everything ultimately comes down to either a query or a prompt, which are the two main classes that you would interface with within LLMware. You're either going to be querying this knowledge infrastructure that's been created, or you're going to be running some type of prompt calling and invoking an LLM, and usually some type of interaction between the two. And then finally, what we're going to be doing in this demo, it's a little bit unique, is we've actually put this whole infrastructure, all of which you'll note is open source tooling. We've put it on an NVIDIA A10 chip, which is a 24 gigabyte of RAM, of GPU RAM. And this is actually, in this case, we're going to be using an AWS AMI. It's an EC2 instance, which is a G5 4X large. It's going to be running on standard Linux. It comes packaged right out of the box with the NVIDIA A10 chip. And what we've loaded into it then, the only thing we've done, we've brought in the LLMware library, and then we've brought in some of the sample code. So that is the setup. I'll just pause here for a second just to see if there are any questions about the architecture before we flip over and we start looking at the demo.
Okay, here's a question. What embeddings model is used for LLMware, and do you have any benchmarks on data ingestion speed?
So you're going to see it. We're going to use two embedding models. We're going to use one out of the box sentence transformer, and you'll see it. I mean, I think the performance is pretty fast. And then we're going to use an industry BERT model, which is basically a standard BERT. It's 110 million parameter that we fine-tuned on contracts. And again, you'll actually see it running some embeddings in real time. We have not done benchmarking of performance with embeddings. A lot of that is going to depend on the underlying hardware infrastructure. So if you throw enough hardware at it and you can parallelize embedding jobs, you can do them spectacularly fast. What we're going to see here is it just running on a single server. And you'll see the times and you can kind of eyeball kind of how fast it is. But yeah, so you'll actually see it.
Cool. I also have a question. Why use two embeddings models?
So I'm going to do it here, really just as an illustration. And this is maybe setting up the demo a little more. We're going to look at two different kind of source documents. One is a set of UN resolutions, United Nations resolutions. It's about 2 years of those resolutions. Each resolution is maybe 3 or 4 pages to 15 or 20 pages, I guess, depending on how much they had to discuss that week. And there are all sorts of things. It's whatever the United Nations, resolved. It could be about, an issue of war and peace. It could be an issue about environment or social justice. It could be any number of things that the United Nations gets involved in. There are 500 PDF documents. It's a fairly general purpose scope. So we're going to use a general purpose, small, fast embedding model because we get good results with it. The second one then that we're going to use is contracts. And we're going to pull down about 80 contracts. And for that one, we're going to use a model that we fine-tuned for contracts and legal documents. We have found that doing that fine-tuning to the industry domain, where the industry domain does have some unique dimensions to it, we found overall it does yield benefit in terms of the accuracy and quality of the retrieval. And again, we'll actually try to highlight that in one of the examples. So why use different embedding models? Because you're going to be looking at, in effect, libraries or collections from different domains. And so where you can start fine-tuning that embedding model for that domain, you can usually get better results.
Okay, very cool. Thank you.
All right, you guys ready?
Ready.
All right. So let's flip over to the demo. I will tell you, I have this on two machines, two identical machines set up. So just in case anything goes wrong on the first one, I do have a fallback that we can take a look at. So this is the machine. This is just the EC2 instance that I mentioned. This is an AWS Linux server. I spared you kind of the launch time and the EBS, getting warmed up and all that stuff. But what I wanted to do is we're going to walk through these three Python files. And I'll quickly open one up, at least so that everybody can get familiar with the recipe, I guess, of the code. And we're going to start. The first example we're going to look at is this UN resolutions one. And again, for what we're going to be showing, just so everybody's clear, all of this is that conceptual architecture. So loaded on this single AWS instance, we have Milvus, we have Mongo, we have all the embedding models, and we have all the LLM models. What we're going to do is we're going to do a one-time pull. So there are some things that are going to get pulled into this, but once the information is pulled in, actually nothing is going to leave. So there's no API call happening behind the scenes. Everything that you're going to see is actually running on this machine. Second thing I wanted to say, this example is posted on our GitHub page in our repository. As Eugen mentioned, we're participating in a kind of a 25-day, promoting open source community, hackathon with Milvus. These are a couple of sample scripts that you can get started in a few minutes and do some really cool things with LLMWare and with Milvus. So just so everybody gets a little comfortable with at least the code logic, I'm going to run through this quickly, but hopefully it'll at least help everybody kind of understand what we're doing. First, as I said, in this case, the embedding model we're going to use is a standard off-the-shelf open source sentence transformer model. It is a mini BERT. Sometimes people think you need bigger and bigger and bigger. We actually have found this mini LM SBERT is a go-to model for us in a lot of use cases because it's small, it's fast, and it's pretty good. So for a general proof of concept, we actually find it's not a bad place to start. And if you think about it also, again, Milvus are the experts in this, but if you're going to build a really, really large collection with really large set of embeddings, having a slightly smaller model with slightly smaller dimensionality actually has a lot of really practical benefits in terms of the overall longer term administration and management of that system. So anyway, we're going to use mini LM SBERT. Milvus obviously is going to be our database. Starting point is you just create a new library. This sets up the construct within LLMware. We're then going to pull down these sample files that we've put in just a public bucket. So if you run pip install LLMware and you run this setup, it's actually going to pull in all these sample files into a local folder structure for you. Now, this step is the parsing step. Once we've downloaded all of these files locally, the parsers actually work with a really simple interface. It's just adding files to a library. What actually that one line does is it actually routes the individual documents based on their file extensions to the underlying parser. It parses, it text chunks, it extracts all the metadata, the tables, the images, and it puts it into a text collection. So you're going to see this step unfolding across these 500 documents. And then there's also a really simple interface to install new embeddings. We're going to apply it to that model. We're going to put it in Milvus. Status Manager is really useful in very large applications. You can poll it to get some real-time visibility on the progress of a large embedding or parsing job. And then once we've done that, and we're just going to run a simple test query here. Obviously, the real fun in all this is to go do the semantic search and start extracting all sorts of things and doing really cool retrieval. I'm just going to do one simple example just to illustrate it, which is a sample query on sustainability issues impacting women, which we think, again, is a good conceptual type of query that oftentimes it's where an exact search fails or doesn't give you the right results because there's a lot of concepts around things like sustainability issues. And then we're going to print it out to the screen. And that's it. So let me go ahead and run it. And we've got 3 examples we want to get through. So hopefully the server didn't go to sleep or anything like that. All right, here we go. So we are parsing, and the parsing status manager, every 10 documents, is printing out this update. It's just pushing it to the console as well as in a database. And so you can see these 500 PDF documents, again, several pages, average length, up to probably 15 or 20 pages. We've parsed 200 of these documents, all in real time, all that information running locally on this server. So we're going to keep cranking through those. Once we're done with all the parsing, then we're going to start the embedding. And what's happening in the parsing is all 500 of the documents are being parsed. They're also being packaged as little text chunks. Those text chunks, each individual text chunk, is ultimately what's going to get embedded. So we're done, 50 seconds, about 10 documents per second. And now we're off running the embeddings. And we're passing the embeddings 500 text chunks at a time. You can see there are about 12,000 total chunks. And we move through it really fast. Now, 12,000 is still a pretty small library, but hopefully this gives you a sense. All of this running locally on a single machine, look how fast. We just parsed 500 documents, we embedded it, and we've just run our first query.
Wow.
This sample code and this sample script, it's in our repository. You can bring it down, you can follow the instructions, and in a few minutes, you can start to do some pretty interesting embedding work.
We have a question from the audience. Are you pulling the PDF files from S3?
Yes. So the PDF files are actually just something we provide. It's just a public S3 bucket where we've put all those sample documents. Of course, in any type of custom use case, those could be in a private S3 bucket, that a company could be pulling from. But in this case, it's just from a public samples file that we make available. That's what was pulled down.
Very cool.
Okay. Now, just a sample retrieval. Again, we're going to look at some more. The primary focus probably is a little more technical in flavor. So how cool it is that we're parsing so fast, or text chunking, or embedding. But I did want to at least show some of the results of this, which is, again, a nice kind of conceptual query. And then what we pulled up with just a single line, running a semantic query against the library. We have the document, we have the page number, and then we have the distance. One of the things we find really interesting is the geometry of the embedding space, and using some of these distances to start doing really interesting things, where you can start defining topic classification, you can start defining that as thresholds of what type of information, how much information to look at based on an embedding distance threshold. And then you can see, and we chop the text at just a short number of characters, just so everybody could quickly read it. But you can see it's done a pretty nice job, with women, with issues that are about sustainability, globalization and interdependence, climate change. You can see many of the topics around, women in development, vulnerable countries, greater gender equality in distribution of economic resources. It's done a pretty nice job of getting down some of the semantic meaning to pull forward, a lot of the interesting context around the query that we gave. Now, I'm going to show another example that's going to be fairly similar. It's going to be a fairly similar type of recipe, but the domain is going to be different. So I'm not going to show the code, but certainly if anybody wants to, we can take a step back and go through it. This is going to do something fairly similar, but this time, instead of looking at UN resolutions, we're going to do the exact same flow, but we're going to pull down 80 contracts. And for this one, again, you can see it's going to parse really fast, those 80 agreements. For this one, though, instead of that mini BERT model, here we're going to use that contract fine-tuned embedding model, because again, what we found is just having a little bit more of a flavor of the key concepts and terminology around contracts, we find actually gives better retrieval results. So we parsed and text chunked those 80 documents in 23 seconds. It was decomposed into 7,643 text chunks. And now we're powering our way through the embeddings of those. Hopefully everybody can see the screen.
Yes. We have another question from the audience. Can you briefly discuss how to ensemble the models together in the code?
I'm going to show that in the next example. So I'll highlight that, if that's okay.
Perfect.
So this example, again, almost exactly like the UN resolutions one, but this gives you just a very similar recipe. It helps to hopefully show that this is a repeatable pattern. You ingest some documents, they get parsed, you can pick your embedding model, you create your embeddings, and then you can start running some retrievals. Now here, and again, probably a sort of a lightweight hello world kind of example, but we just pick something like incentive compensation. And you can see it did a pretty nice job of picking in words that would be very related to that, even though the word compensation wasn't reflected here, but it did pick up all of these kind of key text chunks around incentive and incentive bonus. Now, one of the reasons I wanted to show this is really coming, I think, to the question that was asked, which is the third example that I want to show. And the third example starts sort of chaining or bringing together these models in a RAG scenario. And it sort of builds on this contract example. So in this example, what we're going to do, we're going to use, it's contract, so we're going to use our contract embedding model. Same recipe, boilerplate. We're going to create a library. We're going to pull down these documents. They're already pulled down, so it won't pull them again. We're going to parse those documents. We're going to install our embeddings. And then we're going to do something a lot more interesting now. So now what we're going to do, once we've created that embedding space, now we're going to load a 1 billion parameter Bling model. So we loaded the industry BERT, that's the embedding model. So that's churning out vectors. You feed in text to it, it gives you a vector output. That vector output then is used to, in effect, identify that chunk of text in a vector space. That's what we're putting into Milvus. That's what's going to help us with all the retrieval. Now, the next step, we're going to load in a different type of model, an LLM, a generative model that takes in text, takes in a context passage and a question, and answers that question based on that passage. It's going to yield text. It's a mini, like GPT, if you can picture that. And it's going to be running entirely locally. So I already did download it from Hugging Face, so it is running on the machine. It will take probably 10 or 15 seconds to load into memory and onto the GPU. So we're going to take this model, and now the interface that we use, the concept, the abstraction within LLMWare, is you create a prompt. Because a prompt ultimately is what you want to do with a model, regardless of what the model is. So now here we're going to load the model. We're going to load this Bling model. And we have just a really simple query. Again, not the most exciting query in the world. We're just going to say, what is the executive's base annual salary? Each of these are employment contracts. They're 10 or 15 pages. You can picture this as a real project. Someone comes in and says, could we get a list of what we offered all of these employees to see? Is it comparable? Are there some differences between them? Are there some outliers? Typically, that would be kind of a manual exercise, especially if it's not 10 contracts, but 100 or 1,000. Here, we're going to ask an LLM to do all of that work using the embedding space that we just created. So we load that model. We're going to go run a semantic query. This goes back and queries the vector space. And then we're going to loop just contract by contract by contract. And what we're going to do for each contract, we're basically going to grab the top semantic retrievals for that contract. We're going to package that into our prompt as a source. What this one line does of adding source, it packages and aggregates all of those query results into the prompt, and then we call the prompt. So we loaded the model, we loaded that context, and then all we're going to do when we actually prompt the model is we're going to ask it our question, and then we're going to print out the result. Okay? And again, all of this, all the orchestration of these models, the embedding space, it's all running locally. The data is never going to leave the server that this is running on. Okay? So now let's run this example. So here, there are only 10 contracts. You can see it moved through that really fast. It's creating the embeddings super, super fast. This is a simple example of only 10 documents. And now here we are, that key step. We're now pulling that LLM model, the little 1 billion parameter, the small but mighty Bling model. We're just pulling it into memory, and then it's going to crank through the inferences really, really fast. And then we're going to take a second or two, and we'll actually look at the results that we've gotten from that.
As this is running, I'm going to give you another question from the audience. I don't know if it's discussed, but at the end of the walkthrough, I would love to learn more about building your own data set from scratch with GPT-4 pineapple emoji.
Okay, cool, cool. All right, so this ran. So all the inferences ran, all the queries ran. It iterated through all of the contracts. And let's show what it actually did, okay? So again, we took 10 contracts, we parsed them, we embedded them, we ran a semantic retrieval with a basic question, you know, what is the executive's salary? And then what we did for each contract, we looped through each contract, we took the top retrievals that we found, basically go out, what's the best information that you found in the RIA executive employment contract? And it was these 4 passages. You can see this one was 0.62 away. This was 0.64, 0.81, 0.84. The prompt, that one line of package up the source, packaged up all of this text with all of the metadata, identifying which source ultimately provided which piece of information. This was passed to the LLM, the small but mighty Bling model, and then here was the model's answer. So the model read this passage, and in this case, found the answer that was sort of right in the middle of that retrieval, and gave us then the correct answer. So what it did, just while we were sitting here, in just a couple of seconds, it went through and it did this for all of these contracts. Now, I wanted to highlight specifically a 1 billion parameter model, not to recommend that a 1 billion parameter model can do everything that GPT-4 can. Of course it can't. Of course it can't. It will make mistakes. It will be wrong. It is not intended to be a replacement for those kinds of models. But what this illustrates, when you've got a great retrieval strategy, even a small model can do meaningful work for you. Now, in this case, the small model is running on a GPU, so it's crazy, crazy fast. But this small model, it can run on your Mac laptop, just out of the box. No quantization, no special treatment of it. It just runs, and it runs inference at a reasonable speed, and it's giving you pretty good quality in a relatively simple extractive key value task, but it's getting the correct answer. And so I wanted to show this to you as, I think, a really good example. This is just a simple RAG use case, but this is a recipe that we think you can replicate and scale to do a lot more complicated things. Your embedding space, we've walked through now 3 examples where you can see how to parse, how to create that embedding space, how to run a query against it. And now we've integrated in that prompt and that LLM model so you can start doing an end-to-end RAG. We have a couple of other videos out on YouTube. I'd encourage you to check them out that walk through this in more detail, walk through some of the fact-checking capabilities, walk through some of the ways that automatically all of this output is produced as JSON-L files. You can push it into an upstream system, as well as a CSV file if you want to push it to a person to say, hey, this is the output that I got. Does this look, accurate? And a person then can quickly review and be the final pass on it. So we've gone through 3 examples. They've all been on this ugly, ugly command line. And so what I wanted to do for those that would like to actually see something a little bit more visual, I have actually also run a web app. Sorry. Sorry. I am going to flip over to right now. So this web app is just a simple web app that's running on top of that infrastructure. And please don't, if there's anything wrong in the UI, my apologies up front. I actually prepared some of this just for this demo. I wanted to give something that would just bring to life what we had just done that wasn't on the console. And I also wanted to use this as a moment just to kind of highlight that in addition to all the cool libraries and consoles and experiments and all that other stuff, we've actually used this exact same infrastructure, with Milvus on some really scalable applications where you can start bringing all the pieces together. So start doing this high-powered retrieval with a local private cloud LLM and all of it running in the context of a private cloud. So what I'm going to jump into, and I know we're a little short on time, I do want to get back to that question on data sets. So I just want to show you one thing that I thought was kind of cool. So this is just a very simple little retrieval screen that we've mocked up. And we're going to go back to that simple question. Like the most simple thing, most basic thing in an employment contract is like, what was the amount of the salary, right? And now, first, I'm going to run this just against a text index, okay? This is not a semantic search. This is just a pure text index on what looks like some pretty basic words, the salary and the amount. And I want you to take a look at what it retrieved and what it prioritized. Well, it makes perfect sense. It has the word salary, it has the word amount. Like, how could it be better than that? But when you're looking for a salary amount, what are you looking for? You're looking for a number. You're looking for the actual amount. So what the text index did is it indexed on the words. It gave you salary amount. But now I want to show you, and again, the question about why would you use a fine-tuned embedding model? Why would you use different embedding models? Or why would you even use semantic search versus text search? Well, here's just, again, a super, super simple little example of it. Now what we've done, the same query, salary amount, but now we've actually run it against our semantic index. Look at what it did. It prioritized a different set of results. And now what's fascinating about this is it doesn't mention the word amount, but it seems to, because it's been run through an embedding space where it's churned on lots and lots of contracts. It understands that amount, actually in many cases, what's more important is getting the actual amount itself. And so it prioritized, it was closer to that query in the embedding geometry, were the passages that actually had the amount in them, not the passage that had the word amount in it. So a very simple little example, but I thought I would just use that just to highlight, right, the power of semantic search and the power then of having an embedding model that's been fine-tuned on a particular domain. Finally, I know we're tight on time, so I'm probably going to give this not the justice that it deserves, but we haven't even really gotten a chance to look at the Dragon models. Again, there's a whole bunch of videos and stuff that we have on this. But one thing I'll leave, and maybe this is something we can pick up in a follow-up session. But what you can actually do then is, and this was the model that we had pulled in, was one of our Dragon DESI models. And just for this UI, we did two ways of doing this, both a text passage that you can directly ask a question to, or you can pull something directly out of one of these contracts. And I'm going to do just vacation and how many vacation days. And now this is running an LLM-based query, a RAG scenario against that document of the employment agreement. And here's what it's given us. The AI model came back, and you can see sub-second response time running locally on a GPU, a local model. It read through the entire contract, called out things out of the embedding space, and gave us the applicable clause, along with the sources and confirmation of where that information was. I'm going to pause here. Again, there's a lot more stuff here. I think we're just scratching the surface, but hopefully this has given you, a few different use cases of an end-to-end private cloud RAG system powered by Milvus and powered by LLMware. I'm going to pause the presentation then here. I'm not going to cover any more demo, but I will just quickly take a breath. I'll come back to that question about how to build your own data set. But maybe, Eugen, just to pause to see if there are any other questions you want me to take before we get to
that. Maybe this one will be quicker. Someone asked, I didn't catch why we're utilizing another 1 billion model for inference. Does our DESI model teach the smaller model, or is there another concept happening here?
It's a great question, and the answer is actually really simple. I just wanted to showcase a couple different things. The 1 billion parameter model, it's really useful if, let's say, you were running that script on your laptop. So, you finish this session, you're kind of excited. You're like, hey, this is kind of cool. Let me go check it out. Let me go to LLMware. Let me pull down the repo or pip install it. You're probably running it on a laptop. A 1 billion parameter model is a great way to get started in a hello world. Say, okay, yeah, I kind of get this. I understand how this works. And it's going to give good but not great accuracy in most use cases. And then let's say you do have more of a professional setup. Maybe you're running this on a GPU server, or you set up a pop-up GPU server that we have another video on of how you can quickly set up a 6 or 7 billion parameter model as your own inference server. If you have that at your disposal, then nothing better. I would always go ahead and use a 6 or 7 billion parameter model on a GPU, because you are definitely going to get better results. So part of what we wanted to illustrate, great to test locally on your laptop with a 1 billion parameter model up to about a 3 billion parameter model. And then when you're ready to move it to more of a production environment or put it on a GPU, nothing better than just swap out the name of that Bling model for a Dragon model for a higher performing set of results.
Cool. Very cool. We have just a couple minutes left here. So I think it would be great to just touch on the data set thing, and then we can wrap up.
Data set is an awesome question. Data sets are the key to all of this. So, when we first started doing this, we looked at a lot of public data sets that were available. They're very geared towards chat, and there's tons and tons of stuff. If you want to improve sort of the conversational fluency, kind of the safety and helpfulness types of quotients, there's awesome stuff that's out there. But our use case was really different. We actually wanted kind of a serious, no nonsense, LLM that could read all these sort of dense contracts and regulatory information and resolutions and compliance and financial news, and could extract, very technical kinds of things from it. There weren't as many data sets that were out there. So preparing that data set, I'd say there are probably, 3 key dimensions to it. The first was assembling some of the raw source materials, which is work in and of itself. The second then was really defining what are the key categories of tasks or instructions or skills that we want to train the model on. And some, might be things like value type. We want to make sure that anytime a model is asked a certain type of question about a who, that it's consistently answering and identifying a person. Or if we're asking about the address of a company, that it's consistently able to respond to, that type of value type. Or it could be a question type. So we spent a lot of time on Boolean questions, yes, no. And the models actually work pretty well. If you ask it a yes, no question, did this happen? Can you terminate, looking at the little text here, can you terminate an agreement for convenience? So yes, no questions as a skill, right? So first, gather your source materials. Second, identify that set of instructions. And then the third, the really hard part, is spend a lot of time in the details to make sure that you're asking the right types of sharp questions. You're building both enough consistency as well as diversity. And then that you're providing the right fact-based kinds of answers to be derived from those contexts. So I would say it was a bottoms-up effort with just a significant amount of kind of care in the design and then care in every single detail about how designing it. Now, I think your question was, can you bootstrap? Can you bootstrap off of GPT-4? And the answer is absolutely. In fact, we provide some really cool tools in LLMWare where all these sort of inferences that you just saw us run actually are all captured in a prompt state. They're saved as individual JSON-L files that can then be consolidated and packaged into an LLM fine-tuning data set that's model ready out of the box. The biggest caution that I would have is less about the mechanical side of gathering that data set and much more about sort of the first couple of points of really giving a lot of thought to, what kind of training objective do you have? What are the right source materials? And then what are the key skills and tasks that you want the model to be trained on?
Cool. Thank you, everybody, for coming. Thank you, Darren, for giving this wonderful presentation. I think it was really cool to see what you guys are doing. And also, it was really cool to see the live demos and just how fast they are. I look forward to, seeing more of what you guys do. And thanks again, everybody. This will be available in recorded form soon. So I'll see you guys all next time.
Excellent. Thank you so much, everybody. Please follow up anytime with any questions.